Hi everyone, welcome to iTech Talks. In this video, we'll talk about how DNS works and usage of Nslookup commands. So let's get started. For us to understand how DNS works, it is imperative we know what is DNS. So let's walk you through with that. So what is DNS? DNS stands for Domain Name System and is used to resolve human readable host names like www.google.com into machine understanding IP addresses. It's basically more like a translating service which translates human friendly URL into internet understanding IP addresses, to put it in a simpler way. It is also like a phone book wherein if you know a person's name and you're looking up for his telephone number, you'll have to probably search in the phone book. Similarly, DNS would help in getting the unique IP addresses associated with those human friendly or human readable host names. So I'll move over to the next slide, which talks about how DNS works. Since we now know what is DNS, instead of moving over to the slide, we'll probably switch over to an online sketchboard. This is a program that is freely available for anybody and everybody to use. It's a tool that I use to make this free-flowing diagram or flowchart, you may call it. If you look at it, there's this client computer, which could be a laptop, a desktop, or anything. So this whole diagram or flowchart would explain how DNS actually works. So I hope by the end of this video you'll be able to understand the whole process of how DNS actually works. So this is the client computer, and when a client computer probably requests for any URL, it could be anything, maybe a www.google.com or a yahoo.com. In this example we have used google.com. It goes to the local ISP DNS server, which could be a Comcast, Verizon, or AT&T, anything. Right, it goes to the ISP DNS server and asks the ISP DNS server, hey, do you happen to have the host record for www.google.com? The ISP DNS server says, I'm not authorized owner of that www.google.com, but hey, I have I'll forward your query to the root hen DNS server, which may be able to help us in this regard. So if you look at this green arrow thing, so the ISP DNS server forward the query over to the root hint DNS server, right? And ask the root hint DNS server, do you happen to have the host record, the A record for www.google.com? Root hint DNS server says, no, well, I don't have that. What I'll do is I'll forward you a DNS server, a name server record for .com, and you can actually reach out to the .com DNS server and then request the .com DNS server if they happen to have google.com host record. So it sends back, the root hint DNS server sends back the IP address of the .com DNS server. Now the ISP DNS server have the .com DNS server IP address. It reaches out to the top level domain TLD.com DNS server and requests for an IP of google.com, which is a host record what we are looking for. .com DNS server says, well, I don't have the .com the IP address of the google.com, but I have the DNS server IP address of google.com. So it gives back a reference to go back to www to the Google DNS server. So now the ISP DNS server has the IP address of Google DNS server. Now it goes to the Google DNS server and requests for a host record of www.google.com. Now, since it's an authoritative owner of Google DNS server, google.com, so Google says, well, I do have the host record of google.com, and it responds back to the ISP DNS server with the IP address of google.com. Now, once the ISP gets that IP address of the host record of google.com, it respond back to the client computer, and that's how the whole DNS works. So when you type in www.google.com on the browser, it goes through this whole process of going to all these DNS servers and then fetching you the final result, which is seen on the browser page. Now, having said that, once this is done, once this process is done, everything is cached locally onto the client computer, so that the next time if we have to do a query for www.google.com, it does not have to go through this whole process, because everything is cached locally on the client computer, and it'll save some time on the DNS resolution. So that's, in pretty simpler words, how the DNS resolution work. It's more like a referral program wherein one DNS server keeps referring to the other, and then so on and so forth, until you finally have the final IP address of the host record of that particular website or URL that you're looking for. So now, since we understand how DNS works, it'll be good if we get to know how Nslookup, we can leverage or use Nslookup utility, as that's one utility that'll come in really handy to troubleshoot a lot of DNS related issues. So let's get started. So this is the command prompt window that I have. I'll type in Nslookup, and when you type in Nslookup, it goes to 192.168.0.1. That's generally the IP address of your router, and this is actually the this would actually have something tagged into the router firmware, which would actually take it to the ISP DNS server. So this is more like a ISP DNS server, acting like ISP DNS server right now. So if we do www.google.com and hit the enter key, okay, so it initially timed out because the default timeout value is 2 seconds, but it gave us the host record for google.com, which is 216.58.196.196. So let's do one thing. Let me just try to open this 216.58.196.196. I think it should resolve to google.com only, and let's see if it actually works. So it's taking its time. Okay, well, nice. It opened up google.com because this host, this IP address that you see is actually a host record of www.google.com. Now, the beauty of this tool is Nslookup. It can actually help you in a lot of other ways. So if you need to, find out maybe MX record or any other record for any other URL, there's a small caveat here which you can use, like set type is equal to any. Here set space type is equal to any means fetch out all the information for Google, the URL that we're gonna enter, or the query that we'll do for DNS. It could be any record that you can find for www.google.com. So now when I type www.google.com and hit the enter key, see, that is awesome. So it'll go and try to fetch all the records that it could possibly find, including IPv6 it found. It even was able to find the name, the top level domain, root hints. Also, you can actually find out much more records than just the host record, which could be an SOA, NS, MX, CNAME, and all those records. So that it'll come really handy when you're trying to find out other other records other than the host record itself. So consider a situation, since these days there are a lot of hacking attempts that we run into. So if for some reason your DNS is compromised, there's a cool thing that we can do here. We can set server 4.2.2.2. Here 4.2.2.2 is a free open DNS server that is freely available for anybody and everybody to use. Hit the enter key. Now if you look at it, it resolves to b.resolvers.level3.net, which means what I'm doing right now is, if unfortunately my DNS was compromised, right, I have bypassed my DNS and now I'm leveraging an external free DNS server source that is 4.2.2.2 to do any kind of a query. So let's say we have to do www.google.com again and hit the enter key. Okay, it timed out. It timed out again. Now the default timeout value is 2 seconds. Now what we can do is set timeout is equal to 10. In cases like these, it really comes handy when you can increase the timeout value from 2 to 10, and now do that query again for www.google.com and see what it does. So it's going to try for b.resolver.level3.net for 10 seconds, and let's see if it, okay, good. So now it gave us an IP address of 172.217.0.68, right? That's a host record for google.com. If you look above, I got something on 216.58.196.196. So a completely different IP address pool, right? So let's try to open this 172.217.0.68 and hit the enter key and see if it actually resolves to Google. Awesome. It also goes to Google. So this can really come in handy. Once we use the different DNS server, which is b.resolver.level3.net, we have a completely different host record for google.com. And this way, I mean, you can actually bypass using your own internal ISP server than to use an external open DNS server in this case. And as I talked about few commands like set timeout, you can always increase the timeout value and give ample time to DNS server to respond to your query. And also set type is equal to any. Now if you are specifically looking for any set type, any specific maybe NS record, then you can, instead of typing any, you can type in set type is equal to name server. NS means name server. Hit the enter key. Type in www.google.com. Hit the enter key. Okay, so it fetches out the NS record for google.com, which is ns1.google.com is the name server that is responsible for google.com. So that's really awesome. I mean, you can use this utility to do a lot of things, especially while troubleshooting hostname resolution issues. So I hope you like this video, and this video has been informative for you. Please do give this video a thumbs up if you like the video, and please do let us know if you want to see any specific videos or specific videos on different technologies. Do mention them over in the comments, and do subscribe to our channel. I hope you like our video. Thanks for watching.